Hey everybody, it's Miss Austin. I'm going to be doing the lesson 20 practice problems. We're doing the odds today. Well, number one, it says, Priya, I bet if the alternate interior angles are congruent, then the lines will have to be parallel. Han, really? We know if the lines are parallel, then the alternate interior angles are congruent, but I didn't know that it works both ways. Priya, well, I think so. What if angle ABC and angle BCJ are both 40 degrees? If I draw a line perpendicular to line AI through point B, I get this triangle. Angle CBX would be 50 degrees because 40 plus 50 is 90. And because the angles of a triangle sum to 180, angle CXB is 90 degrees. It's also a right angle. Han, oh, then line AI and line GH are both perpendicular to the same line. That's how we constructed parallel lines, by making them both perpendicular to the same line. So lines AI and GJ must be parallel. Label the diagram based on Priya and Han's conversation. So they first did say, it says angle ABC is 40 and the angle BCJ is 40. And then they said if I draw a line perpendicular to AI through B, I get this triangle. So let me highlight this triangle for you. Angle CBX would be 50 degrees. CBX. Because 40 plus 50 makes 90. And because the angles of a triangle sum to 180, angle CXB is also 90 degrees. Because we learned today that angles of a triangle add up to 180. And now we know if two lines are perpendicular to the same line, so since this one is making a 90-degree angle, and so is this one to this line right here, they have to be parallel. Is there something special about 40 degrees? Or will any two lines cut by a transversal with congruent alternate interior angles be parallel? We could have done the same argument with any angle. We could have changed this, right? We could have made it coming in at a steeper angle. The 40 degrees is not special. No. It would work with any two congruent alternate interior angles. Okay? But the big idea is here, if you have parallel lines, you automatically know that alternate interior angles are congruent. But now we can conclude the reverse. If somebody tells you that alternate interior angles are congruent, then you can conclude that these two lines are parallel. All right, number 3. What is the measure of angle ABE? ABE is right here. A couple lessons ago, we learned about these special angles. They're called vertical angles, and we proved them to be congruent in class. And we can now use that fact. Angle ABE is 50 degrees. Number 5. Identify a figure that is not the image of quadrilateral ABCD after a sequence of transformations. So I'm going to go trace this. So basically, if two shapes, if there's a sequence of rigid transformations that come up one to the next, they automatically would be the same. So I don't even care what's going on, but like, look, those two are the same. So there's a way to get from there to there. Those two are the same. Those two are the same. Those two are this. Oops, gotta flip it. But look at this one. Can we see that no matter what, this quadrilateral right here, AMJD, is not. This one right here. Okay, we know that there would be a sequence if this was the same size as this. All the rest are. This is. So we could say quad AMJD. You could say those letters in any order. Not an image of quadrilateral A, B, C, D. My dog is chewing paper in the background, sorry. All right, number 7. Triangle ABC is congruent to triangle A prime, B prime, C prime. Describe a series of rigid motions that would map it onto the other. Sorry, got a little bit off there. Easiest way, in my opinion, is to line up a point to its image. I just chose A, so I'm going to translate it along directed line segment A to A prime. Then I'm going to rotate counterclockwise around A until B coincides with B prime. I could have said C to C prime. Okay, so translate along directed line segment A prime, then rotate on center A prime counterclockwise until, what did I say, B, you could say C too, coincides with B prime. All right, and finally number 9. Select all the angles of rotation that produce symmetry for this flower. You know, some of these you can do without tracing paper. But if you like having it as a tool. And I'm gonna, right? So 45, so I would turn until that one hits, this is the halfway, right? Boom. 45 worked. 60 would be, well, 30, these are not, I was about 30. Where's my dotted? If that's 45, 60 would be about there. No. 90, yes. And then halfway again, which would be 135. Halfway again, which would be 180. So I got 90, 135, 180. There's more after 180, but those are the only ones that are there. We can keep going. All right, guys, I hope this helped. I'll see you soon.